Hey guys, welcome back to another two-dimensional collisions physics in the flesh problem. After a completely inelastic collision between two objects of equal mass, each having initial speed v, the two move off together with speed v over 4. What was the angle between their initial directions? So, first keyword I identify in this question is that there was a completely inelastic collision. And with a completely inelastic collision, that means both objects stick together after the collision. Okay, so if you don't remember that, or if you vaguely remember that, write it down, because writing it down puts it in your long-term memory. So both objects stick together after collision. That's important because that reduces one variable that you need to solve for. Now V2A and V2B are the same. Okay, so here's what's happening in this question. I mean, you've got two objects colliding. They travel together afterwards, and you have to find the initial angle between the two of them. So I'm just going to do a quick sketch here, so you don't have to draw this. Assume you've got one coming from this direction, one coming from this direction. They collide and they go off in that direction. That's a very standard scenario. So in this case, I would drag back their final direction of motion, and I would call this B, that would be A, this is A and B. So what I'd be looking for is theta A and theta B, right? I mean, that's essentially what it is. You can draw the two of them any way you want, this final arrow any way you want. You drag the arrow back with a dotted line, you find the two angles A and B. That's it. That's all you have to do. But why make things more complicated than we need to, right? So imagine we took this scenario and we rotated it for an ideal example where this direction is the x-axis, the positive x-axis, and these two have components x and y, x and y. That would make it a lot easier. And we're not really changing the question because technically here we can also make our coordinate system x and y. I just want to make it simpler. I'm going to rotate this so the x is horizontal because, you know, that's what we're used to. So bearing that in mind, I'm just going to go ahead and say, okay, let's let this be the first mass. It's coming down like that. This is going to be the second mass going upwards like this. And they both collide and end up going in the positive x direction. They move together afterwards. Okay, so this is going to be A, this is B, and this is A and B together. Okay, so mass of A, mass of B, initial speed of B, initial speed of A. And finally, we have MA and MB together. Now, more good news. The question gives us a lot of nice information. Two objects have equal mass. So therefore, MA, we can just call it M. MB, we can just call it M. Each having initial speed v. They both also have the same initial speed. So v1a is v, v1b is v. With the masses in mind, if ma and mb are both m, then ma plus mb is going to be m plus m, which is 2m. And they're traveling at the final speed, so assume we call it v2ab. We don't even have to use that notation in the question, but there it is if you want it. It's moving at v over 4. Okay, so what are we looking for? We're looking for the angle between their initial directions. So remember, take that final direction, drag a dotted line backwards. That's theta A, that's theta B. That's what we're looking for. Let's define our coordinate axes. Upwards is going to be y, to the right is going to be x. Those will be our two primary positive directions. Okay, so as with video 128, with these two-dimensional problems, it's just like the one-dimensional ones, except here you just, instead of doing P1x equals P2x, instead of doing P1 equals P2, and there I just gave away the punchline, you do it in the x direction first and then the y direction. So let's start off with the x direction. We're going to do P1x equals P2x. So P1x equals P2x. So in the x direction, initially, both of these, this is the initial part right here. This is the final part. In the initial part, both of them have an x component, right? Imagine making that right angle triangle with both. So, yeah. Momentum is mass times velocity, right? But because it's the x component, it's going to be m times v times cosine of theta A, and m times v times cosine of theta B. Okay? So, mv cos theta A plus mv cos theta b. And it's a plus in the middle because both x's are going towards the right. They're in the positive direction. Okay. And the final momentum in the x direction it's purely in the x direction. So the mass times the speed, it's going to be 2m times v over 4. Okay, so 2m times v over 4. Now here's a fun part. This is where we do a lot of canceling and make our lives a lot easier. Mass appears in every term. Imagine factoring it out from the left and then crossing it off on both sides. Likewise, if it appears in every term, you can just go ahead and straight cancel it out. Okay, v also appears in every term, so v cancels out as well. Okay, now on the right side, we've got 2 over 4. 2 over 4 simplifies, put a 1 there, put a 2 there. So you've got a 1/2 left on the right, and you've got a cos theta A, cos theta B on the left. Okay, so that's going to be our expression. Cos theta A plus cos theta B equals 1/2. Okay, so at this point, I'm kind of stuck because I've got 2 unknowns in one expression. So next thing I do is jump to the y direction. Okay, so here I'm going to start solving in the y. So P1y equals P2y. Originally, both of them have a y component, right? The y component for mass A is positive, or rather, pardon me, no, sorry. The y component for mass A is negative. Imagine drawing these arrows. In order for these arrows to be placed tip to toe, like that, right? Y is actually going down, x is going to the right. For this one, to get the hypotenuse in that direction, y has to be going up, x to the right. So both x's are positive, but the y for A is negative, y for B is positive. Okay, so P1y, so I'll just do the momentum of B in the y minus momentum of A in the y. So mv sine theta B minus mv sine theta A equals, the final momentum in the y direction, there is no y component here, so the final momentum in the y is 0. Okay, now we can factor out mv sine theta B minus sine theta A equals 0. Okay, so divide both sides by mv. Those cancel out. I mean, technically you could say is mv equal to 0, but mass is not 0, velocity is not 0, so therefore only this part can be equal to 0. And when we do that, we're going to be left with sine theta A is equal to sine theta B, which, you know, by clearly looking at this, you can see therefore theta A must be equal to theta B. Okay, now we take that, we plug it in here, because that's going to make this expression simpler. Theta A is equal to theta B, then I get cos theta A, oops, okay, we get cos theta A plus cos theta A is equal to 1/2. Okay, so cos A plus cos A, they're two objects, they're the same, so when you add 2 of them together, you get 2 of them. All right, so this is going to be equal to 2 cosine theta A is equal to 1/2. Okay, so deal with the numbers. Take the 2 here, divide both sides by 2, so you're going to get cos theta A equals 1/4. Okay, so let's finish solving this over here. Cos theta A is equal to 1/4, so you know how to solve this. You take the inverse cosine of both sides, so theta A is inverse cosine of 1/4. Punch that in your calculator, make sure it's in degrees. You're going to get theta A is approximately 76 degrees. Now in this question, we're not given sig figs, we're given value, so honestly just give your answer to the nearest whole number. Theta A is 76, so there's one answer. Theta B, we said that theta A equals theta B, so therefore theta B, so we can actually say since theta A equals theta B, therefore theta B is also equal to 76 degrees. And that's it for this video, guys. I hope you enjoyed it. If you did, be sure to smash that like button and subscribe to Physics in the Flesh so you never miss a video from me, which, by the way, I post every weekday at 12 noon. Stay tuned tomorrow at 12 noon for video 130, Two-Dimensional Collisions 3. What? Wait, who's back to school? Pumpkin pie recipe. Okay, I'll save that for Halloween. Guys, so that's it for this video. I hope you enjoyed it. If you did, be sure to smash that like button and subscribe to Physics in the Flesh so you never miss a video from me, which, by the way, I post every weekday at 12 noon. So be sure to be on my channel at that time. Guys, As always, if you missed my videos from the past, be sure to click over there on the right. You'll see some of my latest videos there. And other than that, guys, I hope you enjoy the rest of your day. Peace.